let's take a look at cubic and pressure expansivity of a gas. Yes, gas can expand at constant pressure, which we have known, and it can also what? Be compressed at constant volume. So when gases expand at constant pressure, we can study the cubic expansivity of the gas. And we define the cubic expansivity of gas as the ratio of the change in volume from the temperature 0 degrees to whatever temperature you have to that of the initial volume, that is the volume at the temperature 0 degrees Celsius multiplied by the change in temperature that causes the rise in volume, or the change in volume. So mathematically, what we are saying is that gamma, our cubic expansivity, is equal to change in volume from 0 degrees Celsius divided by volume of the gas at 0 degrees Celsius multiplied by the change in temperature. So alphabetically, gamma equal to V minus V naught all over V naught into T minus T naught, which means that change in volume divided by the original volume multiplied by the change in temperature. But for a gas, the volume is directly proportional to the length, so we can equally express this formula in terms of L minus L naught all over L naught T minus T naught. Please take note that this is not applicable to the normal linear expansivity, cubic expansivity, and the superficial or area expansivity you know. So this is only applicable to gas, where you can use the length as the volume, not in solids. So having known that, the V here stands for the volume after the increase in temperature. V naught stands for the volume at 0 degrees Celsius, and T is the final temperature, while T naught is the temperature at 0 degrees Celsius. That is the initial temperature, rather. So for pressure expansivity, yes, this is the ratio of the change in pressure from 0 degrees Celsius to the pressure at 0 degrees Celsius multiplied by the temperature rise. So also we have it as pressure expansivity beta being equal to change in pressure, as I said earlier, and we can also have it as P minus P naught into P naught minus T naught, into T minus T naught equal to change in P all over P naught times what? Change in temperature. That is, this is technically a change. That's what we mean. So just like the volume and the cubic expansivity, the pressure expansivity has the same definition of terms. The P is the pressure at the final temperature, P naught is the pressure at the initial temperature, and T is the final temperature, T naught is the temperature at the initial stage. So that is that for pressure and cubic expansivity of a gas.